consider the function f of x equals 5 times the quantity x minus 3 to the 2/3 power. For this function, there are two important intervals, negative infinity to some cutoff value, and a to infinity, where a is a critical number. So let's find a, the critical value. So what I'm going to do is copy this down and do some work a bit down below so I have some space. So 5 times x minus 3 to the 2/3. Okay, so the first derivative here. Looks like I'm going to need the general power rule, which says I can bring the exponent down, leave the inside part of the function alone, and subtract 1 from the exponent. Then multiply by the derivative of the inside part. So it looks like I have 10 over 3 times the cube root of x minus 3 as my derivative. Now, critical values. Let's talk about those. Critical values occur whenever the first derivative is equal to 0 or the first derivative is undefined. So if I try to set this equal to 0 and solve, I'm not really going to get very far in that process, because the only thing that I can do is try and get that cube root out of the denominator. And I could do that by multiplying both sides by 3 times the cube root of x minus 3. But what would happen is 0 times anything is just 0. It would cancel the denominator here, and I get 0 equals 10. But that's not a true statement. And all that's telling me is that's not going to lead to any solutions, so that's not going to help. But what can help is looking at this over here. So the second, why did I write the second derivative? The first derivative is undefined whenever you can have division by 0, for instance. So f prime evaluated at 3. The issue with 3 is in the denominator, I'm going to have 3 minus 3 underneath this cube root. And that's 0. The cube root of 0 is 0 3 times. So this results in division by 0. So it's undefined. All right, so since that's undefined, x equals 3 is a critical value. And it's my only one. So x equals 3 is that value. Now, for each of the following intervals, tell whether f of x is increasing or decreasing. So we're saying on the interval from negative infinity to 3, and then from 3 to positive infinity. We want to know, is the function increasing or decreasing on these intervals? So to determine that, we start a number line and choose some test values around 3. So 0 is a great one, 4 is probably okay too. And we plug these numbers into the first derivative and see if we're positive or negative there. So if I put in 0, let's see what happens. So that would be 10 divided by 3 times the cube root of 0 minus 3, which is negative 3. Now, the square root of negative 3 is going to cause problems because we aren't looking at complex numbers at this point in our calculus. The cube root of a negative is fine, it's still just a negative value. So that means I have a positive divided by a positive times a negative. That result is less than 0. So that means we are decreasing on this interval. If I plug in 4, then 10 over 3 times the cube root of 4 minus 3, which would be 1. So everything here would be positive. So this derivative is positive, meaning that I am increasing on that interval. So what did we say? We were decreasing here and increasing there. Now, for each of the following intervals, tell whether f of x is concave up or concave down. So A still is that value 3 that we found. So we just want to see, are we concave up or concave down? And the test is pretty much the same as we did with the first derivative. We just now do it with a second derivative instead. So we pick test values again. So 0 and 4 are probably pretty decent ones here. We do need the second derivative though. So let's go off to the side and get that. All right, so the second derivative, I am working off of this form right here. So the second derivative would be, so we have the 10/3, bring the exponent out front, so times -1/3. Leave the inside part alone, subtract 1 from that exponent, and multiply by the derivative of the inside part. So that gives me -10/9, and I'll just say times 1 over x minus 3 to the positive 4/3 power. Okay, so don't be intimidated by that positive 4/3 power. Your calculator can handle that just fine. I'll tell you what I'm going to do here. Since we have to throw two numbers into it, I'm going to put this function into the calculator as I see it. So it's really just x minus 3 raised to the, in parentheses, -4/3. Okay, and I'm going to go to the table, delete these values, and all I want to evaluate this is at 0 and 4. And it looks like it's negative on both of those. So that means if it's negative on both intervals, then I am concave down on both intervals. And the question did say to indicate that with CD to represent concave down.